Hi, today we want to go over section 1.3 and 1.4 of Math in 11, the elementary statistic in OpenStax. Section 1.3 is talking about the frequency and the frequency table. But before we start frequency table, we want to talk about the level of measurement. In last section, we talked about the different type of the data, which was the quantitative or qualitative types of data. Now there is another way of classifying data, which is called the level of measure. The data will be classified in 4 different categories based on the level of measure: nominal, ordinal, interval, and ratio. Let's explain each separately. A nominal level usually are the data that are in categories, colors, or names, or labels, the data that are qualitative. Okay, and these names cannot be in order. They are just names. For example, if you just collect the survey responses and as a yes or no or undecided, you're just collecting some names. And you can't put yes, no, and undecided in order. So these types of data are called the nominal. Another type of data is called the ordinal. We have ordinal level of measurement. These groups of data can be arranged in order. They can be names, labels, or they can be numbers, but whatever they are, the qualitative or quantitative, they can't be in order. They can be in order. But the differences between these data cannot be measured. For example, you're collecting some data about the course grades. The grades that you received for each course are A, B, C, D, or F. Okay? But they are not numbers, but they still, you can put them in order. So they are nominal, but since you can put them in order, you can say they are ordinal. Interval level of measurement are for the data that can be arranged in order, and the difference between the data value is meaningful. But there is no starting point. What does it mean? For example, we are collecting data about the different about the events that occur in different years. When you collect the data about the years, you have years of 1000, 2001, 7076 or 1984 or 1492, you have just some numbers as years. Since they are numbers, you can put them in order, and the difference between these numbers are meaningful because you know what's the difference between 7076 to 2024. You know the difference. You can just find the difference between these years. But there is no starting point. I mean, we don't know where's the starting point. We don't have any zeros for that we say, okay, starting point is the year 0, and then after that. We don't have that option here. Okay, we don't have the starting point. These data are called interval. And the ratio level are the data that can be arranged in order. The difference between the data values are meaningful. And this time we have a starting point or the 0. For example, I'm collecting data about the class times. Some of the class times are 50 minutes, some of them are 100 minutes, some of them are 110 minutes. We have some numbers as a class times in minutes. Since they are numbers, I can put them in order. I can find the difference between the times of different classes. And also, I have a starting point. I have a national 0 for that. I know that the 0 for this class times is 0 because we don't have any classes less than 0 minutes. So for sure, all the classes must start from 0 minutes, 0 minute, 10 minute, 20 minute, 50 minute, 100 minutes. So this time we have a national 0 and we call it a ratio level. And just make sure to remember all these level of measurement in order that we talk. Because if you learn them in order, it's easier to understand. Nominal are just names or labels or categories. Ordinals are names or numbers that you can just put them in order. Intervals and ratio are just numbers. Remember that. Interval are numbers that you can put them in order, and the difference between the data values are meaningful. Ratio are you can put them in order, the difference is meaningful, and there is a starting point. In each one, it has one extra characters into the dimensions. So let's look at this example. We want to find the level of measurement of each of these topics. The body temperature in Fahrenheit of an athlete during an exercise. This is talking about the body temperature. Body temperature are numbers in Fahrenheit. Okay, since they are numbers, for sure, it cannot be nominal. It should be ordinal or interval or ratio. I know that I can put the body temperatures, the temperatures in order, so it can be ordinal. And I can find the difference between the temperatures, right? So it can be interval as well. But is there any starting point for the body temperatures? Or for in general for temperatures? Because temperatures can be negative, can be positive. So I don't think we have a starting point. So we don't have a starting point. So it is an interval. The heart rates. The heart rates of an athlete during an exercise session. The heart rates in beats per minute is a number. Okay, so it's ordinal or interval or ratio. Can I put the heart rates in order? Yes, so it can be ordinal. Is is the difference between the heart rates meaningful? Can I find the difference between the heart rates? Yes, so it can be interval. Is there any starting point? Is there any natural zero? Yes, because there is no heart rate less than 0 beats per minute. Otherwise, it's dead. So yes, there is a natural zero as well. So this is called ratio. Letter grades for the Math 11 course. Letter grades are A, B, C, D, or F. They are not numbers. Since they are not numbers, it can be only nominal or ordinal. But if it's just a name or labels, it's not nominal. If you can put them in order, it's called ordinal. Can I put the letter grades in order? Yes, so it is ordinal. Jersey numbers of football players. Jersey numbers are numbers, but we learned on last section that they work as a label for the football players. We can't put the players in order based on their jersey number. Or there is no meaningful difference between the jersey numbers. We can't find the difference because jersey numbers are the numbers that only shows, only works as a label for each player. So it can be only nominal. They are just names, they are just labels. Inches of rain last year. Okay, inches of rain, it can be 4, 10, 100, thousands is number. These numbers, you can put them in order. It can be ordinal. The difference between the inches of rain is meaningful, so it can be interval. And there is a starting point for the inches of rain because we cannot have less than, less than 0 inches of rain, right? So it's ratio, yeah. Now let's start to talk about the frequency distribution. Frequency distribution is one way to organize the data. Organize the data and put them in groups, okay? Especially when we have too many numbers as a data value. So we try, since we want to organize the data and we can't have all the numbers in one table, we try to put them in groups, okay? Each group is called a class. So, and any table that shows the classes classes or intervals of data with the number of data entry in each class is called the frequency distribution table. And the frequency, which we show in tables by F, it's the number of data that exists in each class. As you see in this, we have a frequency table here. The classes are showing the data values. The data values from 1 to 5, 6 to 10, 11 to 15, 16 to 20, and we have the frequency table for each of them as well. In each classes, in the frequency distribution table, we have two numbers for each class. And the first number in each class is called the lower class limits, and the highest number is called the upper class limits. Okay, in each class. For the first class, the lower class limit is 1, the upper class limit is 5. In the second class, the lower class limit is 6, the upper class limit is 10. Now the question is how we can find each of these classes. To find the classes, we need to know the class width. The class width, or the length of each class, tells me how I can organize the data. If I want to find the class width, first of all, I need to know the number of classes that I want to have in my table. Okay? After knowing the number of classes, we usually subtract the maximum data and the minimum data and then divide it by the number of classes. And when you find the class width, you will start from the lowest number on the data set and then add it by the class width. If the class width is 5, you add 1 by 5, get 6 for the second class. 6 plus 5, 11 plus 5, 16 plus 5, 21 plus 5. Okay. After finding all the lower class limits, we start finding the upper class limits. And since we don't want to have any overlap between the classes, if the second class starts at 6, we end the first class at 1 less than the other. And after finding the first upper class limit, we can keep adding by the class width again, 5 plus 5, 10 plus 5, 15 plus 5, 20 plus 5, to have all of the lower and upper class limit and having all the classes. After finding all the classes, we need to count how many data in the data sets are between 1 to 5. After finding them, after counting, we just put 5 as the number of data that exist in that class. And after finding all the frequencies, the number of data in each class, we may need to find the relative frequencies because those numbers are the frequency, the number. Frequencies shows the number of data in each class. Okay. But the relative frequency usually tells me the percentage of the data in each class. And how we can find the relative frequency by dividing the frequency of each class by the sum of all frequencies. If I go back to the previous example, for example, in this table, if I want to find the relative frequency, first I need to have the sum of all frequencies. I need to add all these frequencies together, which is 5 plus 5, 5 plus 8, plus 6, plus 8, plus 5, plus 4. Which is 5 plus 8 is 13, plus 6 is 19, 19 plus 8 is 27, plus 5 is 32, plus 4 is 36. And then to find the relative frequency, we divide the frequency of each class by the sum of the frequencies, which is 5 divided by 36, so 5 over 36. You can keep it in fraction or you can change it to decimal. After changing to decimal, if you multiply it by 100, you get the percent. For the second class, I have 8 as a frequency divided by 36. It gives me the relative frequency. And if I multiply it by 100, it gives me the percentage. Another part of the frequency table is called the cumulative frequency distribution. To find the cumulative frequency distribution, we need to add the frequency of each class by all of the previous one, by the frequency of all the previous one. For example, I go back to this. So the frequency of the first class is 5. Keep it the same because there's no previous classes for this one. But for the second one, since the frequency is 8, I need to add it by 5. The third one is 6. I need to add it by all the previous. 8 must be added by all the previous, which is called the cumulative frequency distribution. These are the definition. Now I want to start working on an example and complete a frequency table. So first of all, it says these data represent the time in minutes spent which is spent reading a political blog in a day. Construct a frequency distribution using 4 classes. I said we need to know the number of classes as the first step. We want only 4 classes. To find the classes, we need to find the class width. The class width is based on the maximum number, the minimum number, and divided by the 4 because we only want 4 classes. If you look at this data set, the minimum number is 0. The maximum number is 19. So if I subtract the maximum and minimum and then divide it by 4 because I want 4 classes, we have 19 minus 4 divide 19 minus 0 divide by 4, which is 19 divided by 4 is 4.75. And since the class width is not a whole number, to make the classes, just more smooth, we need to round it off. And remember, we always round it off. And we get 5 as the class width. So writing the classes first. I always start from the minimum number, which is 0. The first class is 0. Since the class width is 5, I need to keep adding by 5. 0 plus 5 is 5. 5 plus 5 is 10. 10 plus 5 is 15. Then I want to start writing the upper class limits. The upper class limit, as I said, since we don't want overlap between the classes, if the second class starts as 5, the first class must end at 4. Since the third class starts at 5, the second class must end at 9. Or you can, after finding the first one, you can keep adding by the class width, which is 5. 4 plus 5 is 9. 9 plus 5 is 14. 14 plus 5 is 19. And after writing the 4 classes, we need to make sure that the maximum number, which is 19, it's in the last class. We have all the classes now. We want to start finding the frequencies. Then how many data they are in each classes. So the first class is from 0 to 4. How many numbers do we have in the data set from 0 to 4? 0 to 4. 1, 2, 3, 4, 5, 6. How many classes do we have from 5 to 9? 1, 2, 3, 4, 5, 6, 7. How many numbers do we have from 10 to 14? 10 to 14. 1, 2, 3. And how many numbers do we have from 15 to 19? For the remaining numbers that we have in the data set, it's 1, 2, 3, and 4. And if I add all the frequencies together, 6 plus 7 plus 3 plus 4, it gives me 20. which means I have to have 20 numbers in the data set. And if I count the numbers, if it's 20, that means I have all the numbers in the table. Okay, after finding the classes and the frequencies, I want to find the relative frequency first. The relative frequency, as I said, we need to divide the frequency of each class by the sum of all the frequencies, which is 20. 6 divided by 20. You can keep it as a fraction if they ask you, or you can change it to decimal, which is 0.3. And if you want to write it as decimals, you need to multiply it by 100, and 0.3 multiplied by 100 gives you 30%. That means 30% of the data are in the first class. For the second class, I have 7. Divide the frequency by the sum of the frequencies. 7 over 20. If I change it to decimal, gives me 0.35. And if I multiply by 100, gives me 35%. The next one, 3 divided by 20, which is 0.15, multiplied by 100, gives me 15%. And the last one, 4 divided by 20, which is 0.2. And then if I multiply by 100, it gives me 20%. To find the cumulative frequency, I need to add the frequency of each class by all the previous one. So 6, the first frequency, doesn't have any previous classes, so we'll just keep it the same. But the 7, which is the second frequency, must be added by the previous one, which is 6. And 7 plus 6 is 13. 3 as a third frequency must be added by all the previous ones, which is 7 plus 3 plus 7 plus 6, which is 16. And the last frequency, which is 4, must be added by all the previous one. And it must be added up to 20. It must be the same as the number of the sum of all the frequencies. Okay? Now, the only column that is left is finding the midpoint. Midpoint is a point which is exactly in the middle of each class. Okay? So we just have to look at the classes. The first class is from 0 to 4. What point is exactly in the middle of 0 to 4? It's 2. Yeah, good. How we can find it? By just adding the lower class limit by the upper class limit and then divide it by 2. For the second class, I can add 5 by 9, the lower class limit by the upper class limit, and then divide it by 2. 5 plus 9 is 14, divided by 2 is 7. Or I can just keep adding and dividing by 2, or after finding the first one, since the class width is 5, I can keep adding by 5. 2 plus 5 is 7. 7 plus 5 is 12. 12 plus 5 is 17. Okay? Now you see here's all the information on the table. Now another example that you can keep working on that. Now let's look at the next example. In this example, the height of 100 male semi-professional soccer players given on the table. We have the heights in classes, we have the frequency, and we have the relative frequencies. Now it's asking the percentage of heights that are from 67.95 to 71.95 inches. Whenever it talks about the percentage, remember that we only look at the relative frequency column. The heights from 67.95 to 71.95, which means these two classes. So I only have to look at these two classes. And since it's asking about the percentage, I need to look at the relative frequencies. What is 0.17 plus 0.12? It's 0.29. And if it's asking about the percentage, multiply by 100, and it gives you 29%. Next question is finding the percentage of the heights that are more than 65.95. More than 65.95, that means starting from this class all the way to the last class, all of these classes together. And if I keep adding the relative frequencies, all these numbers together, and multiply by 100, it gives me 77%. Next question is asking the number of players. This time it's not asking about the percentage, it's asking about the number of players. Number of players, that means that exact frequency that we have, not the relative frequency. The number of players in the sample who are between 61.95 and 71.95. 61.95 to 71.95, these classes. Okay. But it's asking about the number of players. That means this time only add the frequencies, not the relative frequency. If you add all the frequencies, 3 plus 15 plus 40 plus 17 plus 12, it adds up to 87. And the last question, it says, what kind of data are the heights? So heights are numbers. Numbers are always quantitative. And we said last time that the quantitative data are always in two groups of discrete or continuous. Discrete means they cannot have any number. Continuous means any number we can have. And since you know the heights, it can be any number. We can have it in decimals as well. So it's a continuous. So it's quantitative and it's continuous. Okay. Now let's talk about the section 1.4. Section 1.4 also is more about the definition. We want to learn about experimental design and observational studies. We have two types of study for collecting data. When we set up a statistical study, we have different methods to collect the data. The two important ones that we talk in this chapter are called the observational studies and experiment. Experiment is when we have a study that we apply some treatments on the people and see how these treatments affects on any individual. But observational studies are the studies that we collect data from observing or measuring some characteristic. Let's look at an example. It says researchers conduct a study to determine whether magnets are effective in treating back pain. Pain was measured using the visual analog scale, and the results are given below. And these are the results. It says the reduction in pain level after the magnet treatment, when we have 20 individuals, the mean is this number and the standard deviation is this number. And as a result, for reduction in pain level after the sham treatment, on 20 individuals, the mean and the standard deviation. Okay. Now it's asking, is this a study an experiment or an observational study? Yes, this study is an experiment. Why? Because it's using a treatment. When they have a magnet treatment or the sham treatment, and they want to see if they are effective on treating the back pain, and they are using the treatment, I mean, that's experiment. That's experimental study. Let's look at the next example. It says determine whether the description corresponds to an observational study or an experiment. It says research is conducted to determine if there is a relationship between the height and childhood exposure to measles. Okay, they want to see the relationship between the heights, okay, and the childhood exposure to measles. So that means they need to collect data through measuring the heights and observing, if they exposure to measles. So they're collecting data through observation and measurement, which is observational study. So in any experimental study, the purpose of the study is investigate the relationship between the two variables. And these two variables are called the explanatory variable and the response variable. Explanatory variable are the variable who make changes. And the response variable is the variable who affected by the explanatory variable. For example, if you want to see the effect of a type of medication on blood pressure, in reducing the blood pressure, that medication, that pill is an explanatory variable because it can affect the blood pressure, and reducing the blood pressure is a response variable because it can be affected by that treatment. An experimental unit is any single object or individual in that study who can, that can be measured. It's called experimental unit. Every individual person whose the blood pressure can be measured to see if that pill is effective, it's called experimental unit. And the different values that we have for the explanatory variable is called treatments. In all of the experimental study, researchers usually apply treatment before observing any responses. Okay? After the treatment is applied to those groups, they observe the result to see how much that treatment was effective. But when they are giving the treatment to the part, they usually give the treatment to the part of the population, which is called the treatment group. And the other part of the population, which they are called the control group, are receiving a placebo. That means they are not receiving treatment, they are receiving something which is called the placebo. And placebo is a harmless fake treatment, like a sugar pill, which is not change anything. Okay? So remember, in any experimental study, we have two types of group. We have two groups, treatment groups and control group. Treatment groups are receiving the actual treatment, and the control group receiving the placebo, which is a fake treatment. Okay? We have an example before we move on. It says the researchers want to investigate whether taking aspirin regularly reduces the risk of heart attack. 400 men between the ages of 15 and 84 are recruited as participants. The men are divided randomly into two groups. One group will take aspirin, which is the treatment group, and the other group will take a placebo, which is the control group. Each man takes one pill each day for 3 years, but he does not know whether he's taking the aspirin or the placebo. At the end of the study, researchers count the number of men in each group who have had heart attacks. Now let's see, in this study, what's the population? Population is all the men between ages 15 and 80, because the study is just on those men. And the sample, it's just 100 men with ages between 50 to 84 who participated in this study. Sample is always a part of the population. What is an experimental unit in this study? Experimental units means one individual who has been receiving a treatment and they have measured the effectiveness of that treatment. And in this study, experimental unit is every one individual man who received the treatment, right? Who participated in this study. Explanatory variable and response variable. Explanatory variable is the variable who affect The other variable, response, is the variable who has been affected. What is supposed to affect something? The pill. The medication is supposed to affect the risk of heart attack. Okay, so that medication, that pill, it's the explanatory variable. That oral medication, whatever pill that they're receiving, it's the explanatory variable. And the response variable is the chances or the risk of heart attacks. Okay, the risk of having a heart attacks. And the treatment is the aspirin. Okay. Okay. So when a researcher design an experimental study, they have to pay attention to some factors who may ruin, the result of the study. And one of those factors are called confounding variables. Confounding variables are occurs when the experimenter cannot find a difference between the effects of different factors on the variable. For example, it says a coffee shop owner remodeled her shop at the same time her shop, and at the same time the nearby mall has its grand opening. If the business on the coffee shop increases, it cannot be determined whether that's because of remodeling or because of the opening of the new mall, which is called confounding variable. The researcher cannot tell the difference between the effects of different variables. But to control the effect of those variables, there are different methods that the researcher can use to reduce the effect of different variables on the result of the study. First is completely randomized design. Completely randomized design means when they are choosing the peoples for the treatment group or the control group, they choose the people through the process of a random selection. Another method is called the randomized block design. The randomized block design means when they're putting the peoples in groups, they choose the groups of subject that they have a similar characteristic. For example, when they want to see the effectiveness of a medication, they can put the population into two groups as a men and women because men have the same characteristic like the women that they have the similar characteristic to each other. Another method is called the match pair design. Match pair design means comparing the two treatment and the placebo groups by using the subject that they are matched in pairs, or they have somehow related to each other, or they have similar characteristics. And the next method is a rigorously controlled design, which means the researcher must carefully assign subject to different treatment groups or the placebo groups. And they put the peoples in a way that are more important to the experiment. We have an example. It says to see how well an SAT prep program does on raising a score, the scores of a group of students who had taken the prep program were compared to a group of students who had not. Are these two samples match pair? Match paired means the subject must be somehow related or have a similar characteristic. The two groups that we have here, one group had taken the prep program and the other didn't. Okay. Are they match paired? No, because they don't have a similar characteristic when one group received the prep program and the other had not. Okay. To have a good design of any experiment, the researcher must include the replication, blinding, and randomness. What does it mean? Replication means repeating the experiment. If they want to have a good result for any experimental design, it's good that they repeat that experiment on more than one individual. And it's better that they choose a sample size that are large enough to show the effect of that treatment. Okay? Blinding is a technique that the researcher can choose when they are giving the people a treatment or the placebo. Do not let the subject know whether each of them are receiving a treatment or placebo. When the subject do not know if they are receiving a treatment or the placebo, they can reduce the placebo effect, because they don't. It helps the researcher to see the effectiveness of treatment, not the people's behavior, since they think that they are receiving the treatment and they have a change on their behaviors, not on their health. Double blind occurs when the subject doesn't know if they're receiving the treatment or the placebo, and even the researcher do not know if any of the subjects are receiving the treatment or placebo. This is called double blind, and a third party will do that in the study. And the randomization, which is used when the subjects are assigned to different groups through the process of random selection, which means that everyone has a chance to be chosen in each of those groups. Let's look at this example. This is to see how well a weight loss drug works. A doctor randomly selects which people in the study will be given the actual drug and which will be given the placebo. All study participants think they are getting the weight loss drug. Is this a blind experiment or the double blind experiment, or neither? Since the subject do not know that they're receiving the treatment or the placebo, that is a blind experiment. But to be double blind, the researcher shouldn't know as well. But as we see here, it says the doctor randomly select the people and choose who received the treatment, who received the placebo. So that means the researcher knows. So that's not a double blind. It is only a blind experiment. Okay? Now, after going over the experimental study, we want to talk about the observational study. For observational study, we said that the data will be collected through the process of observing or measuring some characteristic. But for observational study, we also have three types of studies: cross-sectional study, retrospective study, and prospective study. Cross-sectional study means the data will be observed or measured or collected at one point in a time. That's it. Retrospective study means we need the data that are collected in the past. And since we can do it on our own, we need to use the records or interviews from the past studies. And the prospective or longitudinal study are when we need to collect the data in future. We start the study now, we observe and collect some data, but we also need to do that in the future as well. Collect some data in future. Next example is identify the type of observational study, if it's a cross-sectional, retrospective, or prospective. It says a sociologist is in the process of surveying single parents. What type of study is that? Okay, the process of surveying single parents. It will be occurring one point in time, which means it's a cross-sectional. Okay? And the last part of this section is talking about any study is a statistical significance or practical significance. Statistical significance means the results are coming from a statistical study, and the chance of occurring that event is even less than 5%. For example, we getting 98, we know in each birth we have a 50-50 chance of getting a girl or boy. But it says getting 98 girls in 100 random births is statistically significant, okay? Because that's an extreme outcome, which is not likely from not coming from a random chance. But if you get 52 girls in 100 births, it is not a statistical significance because that's completely by random chance. But the practical significance is sometimes in some study we get the result and we see that the result is statistically significant, but it's not practically significant. It's, we see that some treatments are effective statistically, but it's not actually practical in real life. For example, it says in a trial of weight loss programs, 21 subjects on Atkins program lost an average of 4.6 pounds after 1 year. Okay, this result is completely statistically significant because it's not by random chance, it's coming from a study. But losing only 4.6 pounds after a year, following a diet for a year, it is not worth of the time, the cost, and the effort that each people do. So that means this is not a practical significance.